I have done it again. I spent about 2 hours working on my computer programming again, as I love to do on weekends when I have time. I came home after visiting my mom for the holidays and I continued where I left off on my Rust programming language project. I'm going to share my screen so you can see what I have done and exactly how it works. I will explain some things. Okay, so I have some files here. I've been researching the bitmap file format here, finding some very interesting information, and I have a whole mountain of code, and there is where I have been backing up my code to. And see, I'm going to show you how this works. So here I have my console open. I'm going to clear the screen of all that text there, and I'm going to show you what things look like. Okay, so I have this folder here, and there's no files in that particular folder. That's my output folder, and here is my files of my current project here. And the source code, all of my source code for this project, I already did the binary bitmap project in C, and it's an ongoing project that I'll probably spend the rest of my life on as I continually improve it. But this is the Rust programming language code, and Rust is kind of a newer programming language, invented in 2010 if I remember. And it's very similar in some ways to C, but in other ways it's very different. But this isn't a whole tutorial on the Rust programming language. But what I will tell you about the Rust programming language is it's very strict. It's more strict than the C programming language. For example, you have to specifically declare variables and their type, kind of like you do in C. However, if you tried to pass an 8, 16, or 32-bit integer to a function expecting a 32-bit integer, it would just pass automatically. It wouldn't care. Integer types can be converted between other integer types. They're all kind of interchangeable. But Rust is very strict about its type system. Now I'm going to show you, well, first I should show you what the code does, and then I will show you exactly how it works if I can figure out how to do that. So now there are no files in this folder. However, I am going to run the command to compile and run this code. And it displays the number of bytes in a row of the bitmap and the number of total bytes of the file. And you'll see that this file just appeared in this folder after I ran that command. And when I look at this file, it is a checkerboard, because that is absolutely my favorite pattern in the whole world, is the checkerboard. Now I can modify the code, and I'm going to show you something very specific. If I comment out this line of code and put this code in here, then it will change what the colors of the checkerboard are set to. I use global variables to determine the black and white squares. I can change the black and white squares to any other color. So now when I view the image, it's no longer black and white. It's like a purple and pink sort of madness. It's really kind of cool. So anyway, yeah, you can see that I can modify things. So now that you've seen that my program can create checkerboards of the colors that I like, let me explain a few details. Actually, I'll show you this file again. Notice it's 500 by 512 pixels. Well, there's a reason for that. So the main function calls this function here, and I have several little variables here. I have the variable that's going to be the name of the file and where it's stored, and I have the width and the height and the square size, and that is how many pixels, a large both wide and high each square on the checkerboard is. And notice it declares a vector of 32-bit integers, unsigned, that's why it's U32. And it calls the chastity checker function. Now the chastity checker function is a complete clone of what I had done in C, with the exception that it uses some object-oriented features. It uses the vector instead of writing the pixels to an existing array. So what it does here, this chastity checker function, it declares all these variables, that are based on the arguments I give it, and it does this very clever loop that's kind of my own invention. Well, it is my own invention. I wrote all this code that alternates black and white pixels while it creates a vector, and the result is a checkerboard. And it takes some very clever conditionals, and it indexes that array that I showed you earlier that determines what the colors are, the U32BW, and that stands for unsigned 32-bit integer black and white. That's just a very short way of saying the same thing. So anyway, I could go on forever just about how this one works, but I feel like it would take an hour just to explain how this one-page function actually works. However, you might wonder, well, how is the file actually written to, how does it write to the bitmap file? Well, there's the clever part of it. Now, some of these functions are not used, and you'll notice that I have a thing that says allow dead code. That's because the compiler complains if you have code in the file that you don't call that function. So you have to put that little disclaimer before each function, just so the compiler won't scream at you with warnings and stuff. This language is so strict to the point that it's kind of annoying, but it has its benefits as well. Now this is the function that I wrote, and I just finished it tonight. It saves the vector that was created by the other function. It saves those pixels to a bitmap file. And it's actually a much, much larger function because it has these variables that are going to loop through all the pixels. And it does all this math to calculate what the size of the file is going to be, which is technically optional. However, it is traditional that the bitmap file at address 2 stores the number of total bytes of the file. But anyway, basically, now the fputInt function is a special function I wrote, and this function requires the other function I wrote, so I need to show you that function. The fputInt function puts a little endian integer, it writes it in pure binary format instead of text, to the file at the very specific address. So by researching the exact address of the header and which data it contains, that's how I knew how to write all the information in the right order. So basically this function is handling all the different things. So what you'll notice here is first it writes the 2 bytes that identify the file, then it writes the file size, then it writes the address of where the pixel data starts, called the pointer. And then this is hexadecimal C, also known in decimal as 12, and that's the size of the DIB header. And so there's 12 bytes in this version of the format. And then I have to specifically declare width and height as U64 because the function above actually requires U64 as the integer. So you just have to make sure that it casts the type to be the size of integer that it expects, but because they're not interchangeable like they are in C or C++. But anyway, and then the bits per pixel, the number of color planes, all that data, all this is the header. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 different numbers that are written in the correct order at the right sizes. And it pads with extra bytes. For example, this only really requires 4 bytes, but I have it as 8 bytes to account for the extra stuff. It's very interesting how that works. But anyway, so after that, this is the real heart of the function. After we write the header that describes the bitmap file, then this right here is the heart of this function. And basically it cycles through every single pixel, and it does it in a backwards order because bitmap files are stored, the bottom most pixels in the image are stored at the top of the file, so it's weird. But anyway, so it uses X and Y coordinate variables. You know, that's basic geometry stuff. And it stores that specific element of the vector into a variable named pixel. And then it extracts the red, green, and blue values of the portions of that pixel, and then it pushes those bytes onto a new vector. You'll notice that if you go earlier, notice how it's showing there, it's a.push and those 3 things. That's because A is the name of the vector, and this is a vector of size U8, so it's 8-bit bytes. So it's actually creating a vector that contains all the bytes of the pixel data. And the reason it does that is precisely because it's a speed benefit. Because here is where it actually writes that information to the file of all the pixel data. And it will display this message if something goes wrong, if there's a file I/O error. And then notice it has this byte count variable. That's because Microsoft requires that there is a multiple of 4 bytes in every row of the pixel data. So it does this conditional statement. So if it's not divisible by 4, it does this loop, and basically it adds extra 0 bytes until it's a multiple of 4. It's very clever. If you know about conditionals in programming, then you would probably understand it. But basically all of this code was transferred from my other C programming language project that took months to do. And the bitmap writing function is not the only one I did. I also did this one that saves it as a portable pixel map file. So the end result is that the image would look the exact same way. However, it's just a different format. But it basically, either way, you still get the checkerboard. Now, I've probably shown enough code right now, and I've probably confused anybody who's not very familiar with programming. But basically, that's kind of how the code works. So it creates bitmap files. I'm going to close everything that I have here. Type exit, close that window, and then, okay. So anyway, that's what it currently does. Now, when I first began my binary bitmap project, the focus was on black and white images, and writing a checkerboard function was the absolute bare minimum of what it's supposed to do. And then I also later added some extra features to the C programming language version, where I could write a very specific pixel or write a rectangle at a specific part of the screen. So if I wanted to put like a green rectangle at some weird location, I could do that. But basically having a checkerboard and then doing other types of designs and art on top of that checkerboard is basically the idea. And I also have a few videos of the spinning polygons that I did. And it was complicated how I did those, and I recorded a separate video on how I made those. And in time, I will probably learn how to do similar things with the Rust programming language. And I'll probably use the same method of calling an external program to generate those polygons if I go that far with this project. However, it has been an exciting experience learning a new programming language, and at this point I can't say if I like Rust more or less than I do C. I think I still have a preference for C, but that's obvious because I've used the C programming language for well over 10 years now. So I already know quite a bit about how the C programming language works. Plus, it's a much older language and it is no longer in active development. Nothing about the language changes, which I like things to stay the same forever. So anyway, I guess that's it for this video, but that's my progress so far for what I've been able to do in the Rust programming language, and it's actually very exciting to me. Maybe other people not so much. They probably wonder what I'm talking about. Well anyway, I hope somebody has enjoyed this video.